All right, welcome. Today we are diving deep into what is truly the gold standard for enterprise-grade cloud security on AWS. Seriously, this is the architecture that the world's biggest companies are relying on right now. And by the end of this explainer, you're going to understand exactly how it works, and more importantly, why it's just so incredibly powerful. So let's just jump right into the big question, the one that every single cloud and security pro has to deal with. Your environment is growing, right? More apps, more VPCs. So how in the world do you actually inspect all of that traffic? How do you do it without creating massive bottlenecks that slow everything down or a management nightmare that's impossible to handle? That's the core challenge we're going to solve today. So let's frame the problem itself. We've got two critical types of traffic we have to worry about. First, you've got north-south traffic. That's pretty much anything coming from the internet into your cloud or going from your cloud out to the internet. Then there's east-west traffic. That's all the communication happening inside your network between all your different applications. And securing both? Yeah, that's completely non-negotiable.
Now, you might be thinking, hey, can't I just throw a regular load balancer at this problem? And the short answer is, not really. You see, traditional load balancers, like your ALBs or NLBs, they were built for a different job. Their whole purpose is to terminate a connection and hand it off. They fundamentally change the original packet. And for security inspection, that's a deal breaker. You can't properly analyze something that's already been altered.
And this is exactly why AWS introduced a total game changer, a service that was purpose-built to solve this very specific security problem. So let's get to know the Gateway Load Balancer, or GWLB for short.
So what is this thing? Honestly, the best way to think about it is as a super intelligent cloud-native traffic cop that stands in front of your security appliances. It's designed to do one thing incredibly well. Take all that incoming traffic and distribute it across your whole fleet of firewalls. You know, your Palo Altos, your FortiGates, and it does it all in a way that's completely transparent.
And this right here really visualizes the main difference perfectly. Your classic load balancers are designed to terminate connections. They are the destination. The GWLB, on the other hand, it has a totally different job. It's a pass-through. Its mission is to transparently forward traffic, just steering it over to a security appliance for a checkup without ever messing with the packet itself. It's a fundamentally different beast. And these features are exactly what make it the perfect tool for this job. It forwards traffic transparently, so the original packet is perfectly preserved. It enables stateful inspection, which is critical for firewalls to, understand the context of a conversation. It can automatically scale your fleet of firewalls up or down depending on how much traffic you have. And it maintains what's called flow stickiness, which just means all the packets from one conversation will always go to the same firewall. No confusion, no drop sessions.
So you're probably wondering, how does it pull off this transparency trick? How does it stay so invisible to the traffic? Well, this is where the real magic happens, and it's all thanks to a very clever protocol.
The secret sauce here is a tunneling protocol called GNEV. You can think of this as the core technology, the engine under the hood that makes this whole GWLB system work so flawlessly.
So how does it actually work? Well, it's a brilliant four-step dance. First, the GWLB takes the original packet and just wraps it up inside a Geneve packet. Think of it like putting a letter inside a temporary, special envelope. Step 2, it sends this to your firewall. The firewall opens that outer envelope and gets to inspect the original, completely untouched letter inside. 3, the firewall puts it back in the Geneve envelope and sends it back. And finally, the GWLB just removes that wrapper and the original packet continues on its way, totally unaware it was ever inspected.
So why does all this matter so much? Well, because Geneve preserves the packet's original 5-tuple. That's just the source and destination IPs and ports, basically the core identity of that connection. This gives your firewalls perfect, crystal clear visibility. It's the key to that true transparency we've been talking about. It's how it maintains session stickiness, and it means your firewalls don't need any complex routing changes. They can just focus on what they do best, security.
Okay, so we've seen the building blocks. We have the GWLB, and we have Geneve. Now let's put it all together and actually look at the complete enterprise blueprint.
The entire model, the whole thing, is built around this concept of a centralized inspection VPC. Just think of it as a dedicated, isolated environment where all of your security tools live. This VPC is home to your gateway load balancer and your autoscaling fleet of firewalls. Any traffic that needs to be inspected gets routed here first. Period.
So let's actually trace a packet's journey. Imagine it leaves your production VPC. The first place it goes is the transit gateway, which is kind of like the central train station for your entire AWS environment. The TGW's routing table has one simple, powerful rule. Send all interesting traffic to the GWLB endpoint for inspection. From there, the packet gets tunneled over to a firewall. Once the firewall says, yep, this looks good, it's sent right back to the TGW, which then forwards the clean packet onto its final destination. It's a super clean, elegant, and most importantly, a forced path for inspection.
So what really makes this architecture so much better than the old ways of trying to do things? Let's actually look at the proof.
And this table right here, it just lays it all out. It's so clear. Transparent forwarding? The old methods can't do it. The GWLB? Check. Preserving those original packet details? Nope, not with the old way. GWLB? Check. Strong session stickiness and native support for security appliances with real full auto-scaling? Again, it's a no. The GWLB-based architecture is the only one that checks every single box for modern, scalable enterprise security.
And this architecture enables features that big companies absolutely demand. You can scale your firewall fleet based on real-world things like CPU usage or network throughput. If a firewall appliance fails, the GWLB health checks detect it instantly and just route traffic away from it. Zero downtime. And best of all, you get total, seamless inspection of all your traffic, both between your VPCs and out to the internet.
So let's zoom out one last time, because this really becomes the cornerstone of a global security strategy.
See, the real beauty of this is that it's not just a solution that lives in the cloud. It integrates beautifully with your entire corporate network. Using things like Transit Gateway Connect, you can extend this central inspection hub out to your on-prem data centers and your SD-WAN offices. What you end up with is a single, unified security policy and inspection point for your entire global enterprise. It's huge. And let's be absolutely clear about this. This is not some theoretical design on a whiteboard. This is the go-to, trusted, proven architecture that Fortune 500 companies are using to run their most critical workloads on AWS today. This is the pattern that works. So if we bring it all together, it boils down to a simple formula. The transit gateway for smart routing, the gateway load balancer for transparent distribution, and your fleet of next-gen firewalls for the deep inspection. That combination right there, that's the trifecta. It is the ultimate, and frankly, the definitive architecture for real enterprise-grade security in the cloud.
Which really just leaves us with one final thought to chew on. Your cloud is constantly evolving. It's always growing and changing. So the question you have to ask is your security architecture built on a foundation that's actually ready to evolve right along with it?